So this is the last exercise that we were looking at in 13F, which is to do with Lami's theorem. So you can see here we've got a particle of mass 5 kilos. It's suspended by 2 strings. I'm actually going to start drawing this as we go. So we've got our 5 kilos, and we're going to have that mass going straight down. That's our 5g Newton mass. Suspended by 2 strings of length 5 and 12, which are attached at 2 points at the same horizontal level, 13 centimeters apart. Find the tension in the shorter string. So we need to find something we're going to call T, newtons, T for tension. Now, these 3 numbers that I've circled, hopefully you've recognized those as something that you've seen before, because those are actually the numbers that are the edges of one of the Pythagorean triples or triad triangles. So the 5, 12, 13 is a right-angled triangle that's formed. We don't know what these angles are going to be because you can have any right-angled triangle like 60, 30, 45, 45. So I'm just going to call that theta, and I'll call this one beta. It's a B. So those 2 angles there we don't know. So if I draw this now, we can see we've got 2 strings, which would be these sides, the 5 and 12, 13 centimeters apart off the same horizontal level, which means you've got like a ceiling, and then you've got 2 strings. I'll do the strings in blue. There's a short one and then a longer one, and then your right angle here, and you've got 5 centimeters, 12 centimeters, and 13 centimeters. Now be very careful here. These are not forces, these are lengths, okay? They're not forces, they're not in newtons. They're not actually going to be anything that we use now from this point. It was just for us to recognize this was a right angled triangle. So the next thing that we want to do now is we want to look at finding the tension. So the forces we're interested in, and I'm going to just put those forces in red just so they're very clear. The forces we're interested in is this force down here, this one, and this one. And the reason for that is we're interested in the tension, and this one, because we actually know the value of it and we know its opposite angle. So if we use Lami's theorem, we can use that knowledge of the ratios of the force and its corresponding angle being equal to another force and its corresponding angle. So far we've got 5g over sine of 90 degrees. So remember the way this works is that force and its angle. And then we've got this force here, the T, and its angle is this angle here. So this one. Now the problem is, of course, we don't actually know what this angle is. So we've got a tension over sine of some unknown angle. What we can do though is we can work using the unknowns that we had. So I'm going to put those unknown angles back in. I'm going to call this one theta like I did over here, and beta. Okay. Now, looking at this actually has this quality about it. It's alternate angles. So if you have a picture like this, where you've got 2 horizontals, and actually a better way of drawing it would be like this, and you've got a bisector through here, the angles that are the same size are these angles here, and these angles here are also the same size. So in this diagram, if I was to draw myself a little horizontal here and imagine this as this situation, these angles that I know this one, which is beta, and that means that that's going to be the same as this one, which is here. That means I have a little beta in there, okay? And I've then got 90 degrees. So we can now write this out in a better way. We've now got still the 5g. Now sine of 90 is 1, so it's just 5g over 1, equals t over sine of beta, which we don't know, plus 90 degrees. Now, this is where it's really useful to know your symmetry shifts, which is a sheet that I've given you for your specialist maths. So looking at what happens when we have trig symmetry. So I'm just going to find that sheet for you. Okay, this sheet here tells you a little bit about the shifts. So if you can see, and I'll zoom in so you can see this, you've got here sine of theta plus pi, theta plus 2 pi, theta plus pi on 2. You can see that if you shift sine by 90 degrees or pi on 2, it's the same as the cosine of the angle. So that means, just looking at it here, in this situation, we've got beta plus pi on 2, so that means that this is actually the same as saying t on cos of beta, and you can get rid of the 90 degrees then. And that means that we can find the tension, because it's going to be 5g cos of beta. Now at this point you're probably thinking, well, how's that helpful, because I still don't know what beta is. But remember that this is trig, and it's a trig ratio, and this is a right angle triangle. So cos of beta is going to be the adjacent over the hypotenuse, which here, from beta, adjacent is the 12, and the hypotenuse is the long side, which is the 13. So this actually means that your tension is 5g times 12 on 13. That's the same as 45 if you put it into your calculator, 0.23 newtons.